Okay, so today we're going to be doing a couple more with proportions and triangles. The first theorem that we have is called the side splitter theorem, which is basically just talking about when I have parallel lines in a triangle, it's going to cut the sides proportionally. And so I know that these sides will be proportional to these sides. So what I can do is I can set it up the same way as we did in section 7.2, where I can do like the portion on the top over top of the portion on the bottom. And so what I can do is I can take the purple segment, the top piece over the bottom piece, so that'll be QR over RX. And that's going to be equal to the yellow segment, again, the piece that's on the top, which is QS, over top of the piece that's on the bottom, which is SY. The same thing goes with when I have three parallel lines, cutting two different lines. They're going to cut them proportionally, and so again, I can write it the same way. I can do top over top of bottom, where I can go AB over BC is equal to WX over XY. You can also do left and right pieces as long as you're talking the same way. I think the easiest way to do this, though, is top, bottom, and left and right. Or you can do top, bottom, or left and right. So this one, again, I've got parallel lines. They are chopping these two segments. They're going to cut them proportionally. And so with this one, again, I can go left and right. So I know that the left piece of my purple line, which is X, over top of the right piece of the purple line, which is X plus 5, is equal to, and again, the same thing with the yellow, it's going to be 8 over 12. Then I can go ahead and distribute, cross multiply, making sure that I distribute with the X plus 5. So do 8 parentheses X plus 5 is equal to 12X. Then I can distribute and get 8X plus 40 is equal to 12X. I can then subtract the 8X over to the other side. Get 40 is equal to 4X. Divide both sides by 4, and I get X is equal to 10. The same thing can be done with this second one. Again, I've got three parallel lines. They're going to be proportional. We're going to cut the two lines that I just highlighted there proportionally. The one trick we have here is this entire length here is 11, and just this piece right here is my X. And so I know that when I'm writing this, I'm going to have to write something for just this piece right here, which if the whole thing is 11 and I just want to take off the piece I don't want, it's going to be 11 minus X. Because the entire piece, this whole thing purple is 11, and then I want to subtract off the piece that I don't want, which is the X. And so this would be 11 minus X just right there. And so again, I want to write a proportion with it. With this one, I'm going to go top and bottom. So my piece on the top, I've got of the yellow line, it's 9 over 4, is equal to, on the top I've got 11 minus X over top of X. Again, I can cross multiply, get 4 times 11 minus X is equal to 9X. Distribute, get 44 minus 4X is equal to 9X. Add the 4X to the other side, and get 44 is equal to 13X. That gives me a weird decimal. So I get X is equal to 3.38. Flip over to the back of the notes. Two more problems the same way. Again, parallel lines. I've got my purple and my yellow that it's cutting proportionally. And so I can write it, it's going to be top over bottom. And so I get a over a plus 4 is equal to 12 over 18. Again, I'm going to cross multiply, get 12 parentheses a plus 4 is equal to 18a. I can distribute, get 12a is equal to 48, or sorry, 12a plus 48 is equal to 18a. Subtract the 12a over to the other side, and get 48 is equal to 6a. So a is equal to 8. Then last one on the top right, again, same thing. 3 parallel lines cutting proportionally, so I can write my proportion as top over bottom. 4 over 6 is equal to 5 over x. Get 4x is equal to 30, so x is equal to 7.5. And then the last two, just an angle bisector theorem. And so whenever I see a triangle that its angle, one of the angles is being bisected, this angle bisector, so AD in this case, is going to cut the sides proportionally. So these triangles are going to be similar to each other. And so what I end up having here is I'm turning. So let's see. That's my angle bisector, and so these guys here, those two lines, are going to be proportional with those two guys. And so the way that I want to write it is I can go left over top of right here. And so I can do, I can say that CD over top of DB is equal to AC over AB. And so with these two, again, I see my angle bisector. The QP is my angle bisector. This is the angle being cut in half. And so again, I can write this as these are two similar triangles. So I've got similar triangles over here, two similar triangle over here. And so I can do 10 over top of 18. Oops. Left over right. To be consistent, 10 over 18 is equal to 12 over x. I can cross multiply and get 10x is equal to 216. Divide both sides by 10, so x is equal to 21.6. The second one, last one, same thing. There's my angle bisector. This is the angle being cut in half. So again, I can go left over top of right. I've got this triangle proportional to this triangle. They're similar to each other. And so what I can do is I can write it as 12 over 16, left over right, is equal to x over 20. Cross multiply and get 16x is equal to 240. Divide both sides by 16 and x is equal to 15.